Every one of us has written a program, but have you seen in action what actually happens during execution? Have you ever thought what actually happens at heap, what actually happens at stack, and why do you get segmentation fault or stack overflow errors? Let's have a look.
Let's try to understand program execution. Suppose if you have written a program and the program in execution has to be converted into process. Process is generally divided into these areas. It has stack section, heap section, a section for static and global variables, and a code section separately. Stack section actually handles the function calls and it also stores the local variables. Whenever a main function is called, an stack frame or activation record is pushed onto the stack and all the local variables with respect to that function are also stored in this area. Heap is generally used for dynamic memory allocation. We will talk about dynamic memory allocation in a little while, but let's try to concentrate on other topics here. Special variables such as static and global variables have a special section as their scope is throughout the complete program. Similarly, we have a separate area to store the code section. A process generally cannot access the area of other sections or other processes. It can only access whatever is allotted to it. So, in case of function calls, it can use the stack area which is allotted to it. In the case of dynamic memory allocation, it can use only this heap memory which is allocated to it. Because of this, sometimes we may encounter errors such as segmentation fault or stack overflow. Segmentation fault generally occurs when you try to access a memory location which has not been initialized or which has not been allotted. Generally, if you try to access something which has not been initialized so far, then it will result in segmentation fault. Stack overflow may be caused due to infinite loop. In the case of infinite loop, the entire stack memory eats up and so the complete space over here is occupied. As the process cannot access some other memory other than which is allotted to it and here stack eats up the complete space, we get an error of stack overflow. For dynamic memory allocation, we generally use some of the library functions: malloc, calloc, realloc, free. All of these are library functions which are used for memory allocations dynamically. But before trying to understand how these are used, let's try to interpret why we are using dynamic memory. Suppose if you are trying to keep track of the details of school and its students, then if you have used an array, you have initially used array to store the details of students. Suddenly in the midterm, new student 6 wants to join inside our school. But if as we have used array, we have allocated contiguous memory locations and the memory has been occupied at this place. But what happens in the case of dynamic memory was, we have this heap and whenever is required, suppose if new student is going to join, then we'll try to allocate the memory then at that instant. So in the case of dynamic memory, we try to allocate the memory whenever it is required at a particular instance. It is more practical in terms of real applications when we are not sure of the amount of memory required by an application. It is more relevant in practical scenarios when we are not sure of the memory that is required by our application. The difference between array and heap or stack and heap was, here we try to have the memory locations continuously. But in the case of dynamic memory, we can actually allocate the memory at different locations and try to keep track of them by storing their addresses. malloc is generally called as memory allocation. All of the library function calls which are used for dynamic memory allocation are stored in standard library header file. After including this header file, we can use any of these functions. Let's try to understand how malloc or memory allocation works. As we have discussed, this is used for dynamic memory allocation. Dynamic memory allocation is nothing but allotting the memory whenever it is required at that particular instance. Suppose if we have a pointer. Now I want to allocate memory to this pointer. You need to understand or remember one thing. If I declare a variable integer a memory will be allocated to a, let's say at a location of 100, and then it is capable of storing value at this location. But in case of pointer, the memory will not be allocated initially, and you can actually make this pointer point to any number of memory location. It can point to any size. Suppose if you are having a pointer, it can actually point to an array of integers, or it can point to array of characters or whatsoever. A pointer can point to only one location at a time. But memory allocated at this location can be of any size. Now, if we try to come back to this topic of memory allocation, to allocate memory to this pointer, suppose for example, we need to allocate memory to this pointer, then it can be written as malloc, where I need to allocate the size of an integer. As it is an integer pointer, we can store an integer there. So, I need to allocate memory which is equivalent to size of an integer. As it is an integer pointer, we know that the return type of pointer is void star. I am trying to typecast it to integer pointer. After this statement, memory is allocated in heap. Let's say the location is at 100, then this will be returned to this pointer. Or if the memory is not available, then it returns a null. So, malloc generally returns a pointer to start address or null if the memory is not available. One more modification is, if you want to allocate memory which is equivalent to 100 integers, you can just write it as follows: malloc 100 times size of integer. This actually allocates the memory for 100 integers and returns the start address and places it in this pointer. Now, let's try to understand one more library function which is continuous allocation or calloc. Calloc is actually used for the same thing, where you are having a pointer and you try to allocate the memory for it. But the syntax differs in a small manner. Calloc, here I declare the number of pointers. Suppose for example I want 100 integers and size of int, means it will allocate size of int 100 times, and as it returns void pointer, we need to typecast it to integer pointer. After this statement, 100 memory locations for integers are allocated, and the start address, if it is at 1000, that will be stored in pointer. Or if it is not able to find memory location, then it returns null. So, calloc returns pointer to start address or null in the case memory is not available. If someone asks you what is the difference between calloc and malloc, malloc does not tend to initialize data, but calloc allocates the memory and also initializes data. In the case of integer, it allocates the memory and it replaces each and every location with 0. Or in the case of boolean, it allocates the memory and it stores false. Calloc actually initializes the data at the allocated memory locations, and also malloc actually allots at different locations and try to keep track of them with the help of pointing to its address. All of this happens interiorly. You need not look at its implementation, but malloc need not allocate memory continuously. It may or may not, but in the case of calloc, it is a continuous block inside a heap. So the differences are, calloc actually initializes data and it tends to allocate continuously. Realloc actually tries to reallocate the memory location which has been allocated by malloc or calloc. If you are trying to change, or initially if you have tried to allocate the memory for 10 integers, now you need to allocate the memory for 20 integers, then you can allocate with the help of realloc library function. We have one more library function which is free. Suppose we know that when we allocated memory with malloc or calloc or realloc, it returns the pointer to starting location. Suppose for example you are trying to allocate memory for 10 integers and the start address is at 500. So 500 has been returned to the pointer and the pointer is storing 500. If you are done with the students, suppose for example this is first batch of students who are trying to leave your school and their details is no longer required. To save the memory, we can actually free this space. That can be done simply by writing free of ptr. This is actually the address which is the start of this memory location. So if you write free of 500, all this memory location will be freed from the memory and it can be used to allocate memory for other instances.
We have seen a lot about memory, stack, heap and all the other process sections, and I think it's time to say goodbye. Before that, I want every one of you to think about a data structure which can group all the relevant information together. Suppose if you are the class monitor and if your teacher instructs you to collect all the relevant details of a student. If you take a student, you have to group name, roll number, his address maybe into a single data structure. Can you do that? Think about it. Stay tuned to find out.